We heard earlier in the hour from Public Affairs Officer Lynette Madison talking with Mallory Jennings, the Suitport human testing lead for some tests that are going on with some new equipment here at Johnson Space Center in one of our vacuum chambers in Building 32. We're going to go now back to Lynette Madison, who is going to be this time talking with Joel Maganza, who is the test director for this unmanned test that's going on now. Lynette?
Thank you, Brandy. We are back here in Building 32 in the control chamber in the control room for Chamber B, and I have here with me Joel Maganza, who is the testing director for this test. And Joel, while we were off camera, Joel actually told me a couple of interesting things, and I wanted him to share this with our audience. So, Joel, tell me a little bit about Chamber A.
Well, first of all, Chamber A is the world's largest thermal vacuum chamber. We have it here at NASA. We have used it back in the Apollo days, but it hasn't been used often in recent years. What we're doing right now is doing a lot of upgrades to it, to our LN2 system and our pressure systems on it, and we are trying to get that ready to test the James Webb Space Telescope in 2015 and 16.
That's pretty exciting to have that kind of a new opportunity here.
It is really great to have something like that, something that, like the Hubble, will advance a lot we know about space and take it even further than we already have it now.
So tell me about Chamber B. You said that I asked you if there was something interesting about Chamber B other than it's a thermal vac chamber. And you told me two things. One is that it is the only
human-rated thermal vacuum chamber in the world. We have other vacuum chambers here at NASA and in other parts of the world where a person can be in a spacesuit or in some kind of suit and be in a vacuum environment, but this is the only one that can simulate the thermal and vacuum properties of space.
And the other thing was, you told me something about your very first testing run here. And what was that? When was that and what happened?
Yes, back when Hurricane Ike hit Houston, the Railroad Museum in Galveston, Texas was actually badly flooded. They have a lot of documents and records from the early 1800s. They came to us to ask if there was anything we could do to help. And there is actually a process using the vacuum chamber that we were able to dry out a lot of their old documents and still preserve the paper. As usually when paper gets wet, it's pretty ruined. But using the vacuum process, we were able to help salvage a lot of their documents.
That's incredible. I had never heard that while I was here, so that's pretty interesting. So tell me about today's testing. We've learned that we're testing a Suitport, but tell me about, I saw over here on one of the computer screens all of this diagrams, and there are words on there like strain gauges. So tell me, what is a strain gauge and what you're testing?
Well, anytime we test, what you see in the chamber or what you see visually is just part of the picture. There's a whole underlying iceberg there of all the gauges and data that we're going to be taking. For this test, we're measuring different pressure differentials across the Suitport and the blanking plate. We're also measuring the strain gauges, which kind of tell us how much force is acting on different parts of the blank plate. And what's that going to do is help us when we put a suit in there to let us know what kind of forces are going to be interacting on the frame around that suit and how the delta pressure will take effect.
So what is the delta pressure, and what is the pressure variance in that chamber?
The delta pressure for this test will be, what the delta pressure is, it's a differential in pressure between between two different things. So right now we are at 14.7 psia, which is the atmospheric pressure of Earth. Mm-hmm. In this chamber, we are going to pump down to about 6.4 psia. So we'll have a difference in pressure of 8.3 pounds per square inch during this test. And what that will do is simulate the difference in pressure when an astronaut or a crew member would go out in this suit to what they would be to their environment. Someday eventually we will pump this down to vacuum and have the suit pressurized at 8.3, much like we do with our training for astronauts in the EMU now.
And will you do that with the manned test that's coming up, or will you do something a little different?
For this manned test, we are only pumping the chamber down to 6.4. The test subject and the crew members inside will remain at 14.7. So this is a sort of a low hazard for this, and the farther we pump down, the more we go to vacuum, the more hazardous the test becomes.
And what is the long-term plan for all of these testings? I mean, how many testings will you be participating in?
Me personally, I will be participating in almost all of them. There is a 4-year plan down the road for several other tests and other variations of the Z1 suit and the Suitport with different mechanisms. So we're going to be testing different configurations to determine which one is the best one to drive forward to be used for the next generation of spacesuits and space exploration.
So this test today, again, is an unmanned test. And how long will the test run?
This test will go about 2 days. We're doing 4 runs, 2 runs in 2 days, which should cover all our unmanned requirements. After that, we will be installing the Z1 suit, and then we have 2 weeks of testing with 5 different test subjects after that.
How many people are involved in the testing? How many people work in the chamber?
Well, in unmanned tests, we don't have very many. We have a few engineers, a few technicians, and then a test director and some requesters. When we go to manned tests, it's much more hazardous since we have somebody in a vacuum environment. So we have to add in medical personnel on standby, we have to add in rescue techs, and we have to add in basically a lot more sets of eyes to monitor all the data and to monitor the individual in the suit.
So the information that we learned today, you'll use that to modify the suit, and you're really just looking at the pressures and the forces on this suit. Explain a little bit more to me about that.
The information we're gathering today and tomorrow will be used to basically to verify that this setup is acceptable to install a suit and have a person in that suit. Once we start the man testing, that will tell us what modifications need to be made to the suit, the ingress and egress into the suit and the suit port. But for right now, we're basically making sure that everything is safe so that when we have somebody crawl in, they know they're safe and we can basically take care of them.
Well, let me ask you something about you, Joel. How long have you been a testing director?
I've been a test director here for 5 years. I started out as an engineer in this building, working mostly on Chamber A to get ready for the James Webb Space Telescope. And I've been doing 5 years of test directing for unmanned and manned tests here at NASA.
And what kind of a degree do you have?
I have an aerospace engineering degree from West Point, and I spent 6 years in the military after that before coming here to start working.
Thank you very much, Joel.
Thank you.
Joel Maganza, and we are here in Building 32. Back to you, Brandy, in Mission Control.